Hi, so this video we're going to look at ratio, and it's very much an introduction to ratio, just starting to talk about the ideas behind it. So first of all, you need to know about the notation and what we say when we actually read it. So you will see these two dots which look like a colon, and we say the word to. So if I read this first question out, it says here, so we've got a bag drawn here with some coloured, we could say they're beads or counters in there. And the question is, what is the ratio of, and we would say red to blue. So in other words, how many red are there, how many blue are there, and we put them next to each other as like a relationship. And basically in this instance, all you have to do is just count. So red to blue, there are 1, 2, 3, 4, 5 red. So we would say that that is 5, 2, and the blues there are 3. So the answer for that one would be 5, 2, 3, and that's what we would say, 5 to 3. And what we're basically saying there is the ratio is that, so therefore every time there's 5 red counters, there will be 3 blue counters. So if we were to increase that, we would basically have to have 5 more reds and increase by 3 more blues in order to keep the ratio the same each time, and that's kind of how it works. We can do it, we can write this the other way around, so they're kind of sometimes related to fractions, they're similar to fractions in a lot of ways, but they mean something different. We're relating one part of something to another part, okay? So in this case the whole thing would be the whole bag of beads or counters, and we're comparing different parts of that, so the relationship, how many reds and how many blues there are. We can write it very much the other way around if we decide to as well, so we can say blue to red instead would be 3 to 5, okay? And it's very much dependent on what you are asked to represent and how you write that down. Now what I'm going to move on to look at here is looking at equivalent ratios, which are very similar to equivalent fractions in that what you do to one side you have to do to the other to keep them the same. So this very much relates to that. So here I've said I have 2 bags which are exactly the same. So in other words, I've got another bag, and in that bag I've got the same number of counters with the same number of reds and the same number of blues. What are the ratios now? Okay, so first of all, if we say let's do the red to blue, so the ratio now, well, if we've got 2 bags the same, if one bag's got 5 reds in it, then 2 bags is going to have 10 reds in it, so it's 10. And for the blues, if we go from 3, then in 2 bags we're going to have 6. So the ratio is 10 to 6. But using equivalent ratios in the same way that we would do with equivalent fractions, that can actually be simplified down to 5 to 3, because all we're doing is dividing both sides by 2, okay? And so actually it's a bit of a trick question because the ratio stays the same, alright? The ratio itself doesn't change. All we're saying is that for every 5 red counters there are 3 blue counters. So we can write the ratio in exactly the same way, and indeed that will still work if we do blue to red, because for 2 bags then we're going to have 6 blue and 10 red, which we can still write as 3 to 5. So as I say, a little bit of a trick question. The ratio itself remains the same, and actually it's better if it's in its simplest form, so if it's cancelled down as far as possible. So moving on with that idea then, we can start to think about, okay, can we, if we've got a ratio, so if we've got a situation and we've got a particular whole picture that we're looking at and we've got a relationship between 2 sets of numbers, can we then simplify it down using our knowledge of equivalent ratios? So the first example I've got here, we have 8 to 6 is the same as 4 to what? Now the side relates, the side that you're on is the bit that you're comparing. So hopefully that makes sense. So in this case I'm looking at the 8 and comparing it with the 4. and I'm saying what did I do to the 8 to give me the 4, and well, I actually halved it, so I'm going to do the same with the 6, so that gives me 3. Okay, so all I've done is divided by 2 here and the same there. Okay, likewise with this one, we've got 12 to 8 is equal to what to 2. So the 2 that I'm comparing that I've got the information on is the 8 and the 2. So what have I done to 8 to give me 2? Well, I've actually divided by 4, so I have to do the same with the 12, and that therefore gives me the answer 3. Okay, and then this one here, I've got something to 15 is equal to 2 to 3. So the parts that are equivalent to each other is the 15 and the 3. They're on the same side of the ratio. What have I done to 15 to give me 3? Well, I've divided by 5, so therefore I would have had to have done that to whatever this number was. So I need to work backwards, and I need to times by 5. So if I go from the 3 to the 15, I've had to times by 5. So we do the same with the 2. 2 times 5 is 10. And so the ratio I've got is 10 to 15 is the same as 2 to 3. And it's very similar to working with equivalent fractions, but they're just written horizontally with a dot in between, and really we're comparing parts to each other rather than looking at what part of a whole is. Okay, so please don't get confused with fractions, because they do mean different things, although they have similar rules. Right, the last question then to look at, so this one is a bit of a worded question. So the ratio of my age to my dad's is 1 to 4. If I have 14, how old is my dad? So we can use equivalent ratios here. So the ratio we've got is 1 to 4. Obviously that's my age and that's my dad's age, because the 1 is smaller and you'd expect the child to be younger than the adult, than the dad. So the 1 becomes 14, and what then we're trying to work out what is the dad's age that goes here. So again, you're looking at the relationship. What have I had to do? Well, I've multiplied 1 by 14 to give me 14, so I have to do the same with a 4. And 4 multiplied by 15 is 56, so therefore the dad is 56 years old. So that is a very brief look at an introduction to ratio and how to use equivalent ratios to be able to start to compare parts.